Number 15. Five Eretmochelys imbricata, no clue if that's right, a type of sea turtle, each have a nest. The table shows an original data set of the number of eggs that each turtle laid in its nest. And we have this chart, A, B, C, D, E, and the number of eggs, okay? A sixth nest with 121 eggs is added to create a new data set. Which of the following correctly compares the means of the two data sets? Okay, so before I look at their options, I know we're talking about means. Mean is another word for average. When we are averaging a data set, we are adding all of the data together and then dividing by the number of data points. So if it was, my data points were 1, 3, 6, and 9, I would be adding those together and then dividing by the number of data points, which is 1, 2, 3, 4. I divide by 4, and that gives me the average or mean of those numbers. They love having questions with mean, median, range, mode. Absolutely add those to your list if any of those to study. If any of those don't sound familiar or you can't say immediately what they mean, absolutely know them. They love asking about all of them. So this one is the mean. Now our first one, we have 5 data points, 149, 144, 148, 136, and 139. And our sixth data point, the sixth nest, is 121. There's 2 ways to look at this. Now, you absolutely can find the mean of the first data set, then find the mean of the second data set and compare them. But there is a shortcut, and I'll show you that in a minute. So first, the way you would find the mean of the first data set is you would add 149 plus 144 plus 148 plus, that was a weird 8, wasn't it? 148 plus 136 plus 139. And since there are 1, 2, 3, 4, 5 data points, I would divide that by 5. Now, I wrote this down because I added it up earlier. Didn't want to add it right now. That is 716. Divide that by 5, and you get 143.2. So the average of my first data set is 143.2. Now, for the second data set, nothing has changed in those first 5 numbers. Let me move that out of the way. That's for the next problem. There we go. Nothing has changed for those first 5 numbers. The only thing that's changed is we've added another data point, 121, and now we have 6 points. So I'll take that as a little shortcut, that 716 that I had from the previous one, and I'm going to add 121 to it. So that is 837 divided by 6, and I get 139.5. So now I have the means of the 2 data sets. This is data set 1, and this is data set 2. And let's look at our options. The mean of the original data set is greater than the mean of the new data set. That is accurate. I think A might be our answer, but let's look at the others just to be sure. B says the mean of the original data set is less than the mean of the new data set. Nope, that's not true. 143 is not, 0.2 is not less than 139.5. That one's out. C, the means of both data sets are equal. No, that's not true. And D, there is not enough information to compare the means. That's not true either. So A is our answer. Now for the shortcut. The shortcut on this, you don't actually have to do any math. You don't have to type anything in a calculator, nothing. So here's the thing about means. Averages go up and down with new data based on how, if they are higher or lower than the original data points. Now, what does all that mean? Think about it like when you have grades. If you said like you had a couple of tests and you had an 80 and an 85 on your test. Think about in your classes, if you got, on your next test, you got a 70, is your average, your grade, going to go up or down? It's going to go down. Why? Because 70 is lower than any of your previous numbers. Well, what if on, random ruler out of nowhere. What if on your next test you got a 92? You go, hey, my grade's going to go up. My average is going to go up. Why? Because 92 is higher than any of the previous data points, any of your previous tests. This is always true. So if it was in the middle, it was 80 and 85, and your next test you got an 82, do the math to see how that affects your average. Just a quick little aside to explain what I mean by you have to do the math first here. Let's say I had these four numbers, 80, 82, 85, and 88. To figure out if a new number, like 83, a number that would be in the middle of this range of numbers of data, to figure out if it would raise or lower the mean, you first have to find the mean of the original numbers. So in this case, I would add all those up, 80 plus 82 plus 85 plus 88, which equals 335. There are four numbers in it, so I divide by 4, and that gives me a mean of 83.75. This is what you're saying is the new number higher or lower than. Since 83 is lower than the original mean of 83.75, it would bring the mean for these four numbers, 5, when we add this one, it'll bring that mean down. If the number that I was adding is greater than this mean of 83, let's say if it was just even a little greater, 84, it's going to take the mean of the data set and bring it up. So that's what I mean by saying you have to do math first. And in the other cases that I'm discussing, if the number that you're adding into the data set is completely outside of this range, if it is below it, it's going to bring everything down. If it's above it, it's going to bring everything up, and you don't have to do that mean first. But if it's in the middle, you would. Okay, back to the SAT problem. In this case, I can tell you from my experience, it's going to go down a little bit, but especially when you get a long string of data points, it's going to be harder to tell. Like say if I had 7 or 8 tests, like in that case, like I've said, if I have an 80 and an 81 and an 87 and an 88 and an 81 and 80, and I said 81, So, okay, so I have all these tests that are in the 80s. If I then got a 90, the fact that the 90 is outside of that range, it's bigger than any of them, my average is going to go up, always. If I got a 70, the average is going to go down because it's lower than any in there. If it was in the middle, I would have to do the math. Like if it was an 84, I might go, that's kind of hard to tell with that many numbers. I'm going to have to do the math. So all that being said, let's see what we've got going on over here. We have 149, 144, 148, 136, 139. All are in the 130s or 140s. And the number we're adding is 121. It is lower than every single solitary point. It's going to bring that average down. There's no way around it. If it was in the middle somewhere, if it was a 130 or a 140, and it was greater than 136 and less than 149, do the math. Do the math. Don't guess. It's going to be safest to do the math on that. But here it is very clearly less than any of the original ones. It is going to bring that average down. Likewise, if it had been greater than 149, if the new data point had been, anything greater than 150 or greater, it's going to bring the average up, even by just a little bit. So you wouldn't actually have to do the math. Just recognize it's lower than all the numbers, so it has to bring the mean down, which means, again, A, the mean of the original data set is greater than the mean of the new data set. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.